Hey everybody, Jason here. Welcome back to Linux for Everyone and welcome home. Today is a day that I have been waiting for since April 2018, when I first started hearing rumors that Raja Koduri was heading over to Intel and was going to help them re-enter the dedicated GPU market for the first time in about 20 years. So fast forward to last night, and I am sitting in a Zoom call with a bunch of very important Intel graphics people, and there was this unexpected moment towards the end of the briefing, and it was punctuated by the distinct absence of something. A moment when all the journalists and content creators in attendance kind of collectively realized Intel must have forgotten to show the competitive benchmarks against Nvidia and AMD. After all, cherry-picking data points to prove performance dominance is kind of a staple of the CPU and GPU landscape. And having a third competitor officially entering the discrete graphics space that's been dominated by a duopoly for decades is no small event. So of course we had to ask about this omission. A swift and very honest response came from Intel Graphics Product Director Devin Nekachuk.
We know you're going to test this product yourselves. We know that if we put competitive in here, you're not going to take our word for it. You're going to do that testing. So we thought the most important thing was to look at the experience we offer, really talk about what resolutions, what types of settings, what types of frame rates that we see this product hitting.
That was one of many refreshing moments during this 90-minute briefing that was stuffed full of architecture details, some intriguing new alphabet soup to memorize, and genuinely promising hardware and software features. So in this video, I want to kind of break down exactly what kind of experience Team Blue is hoping to deliver for this first phase of its Intel Arc Graphics family rollout. And I also want to tackle some of the burning questions that we as Linux users are going to have. Now, right off the bat, I want to say that regardless of if you're a gamer or a content creator or both, I think you should definitely pay attention to this series because, in my opinion, Intel is doing a lot of things to address both of these audiences. Something that really stands out as well is Intel's going against the grain with this launch. While AMD and Nvidia, they typically launch their flagship desktop GPUs first, and then they introduce more, mid-tier and mainstream SKUs, and then they go into laptops. Intel is taking this mobile-first approach to crashing the discrete graphics party, and they're doing so beginning this April at the lower end, the lowest end of the performance spectrum. By summer 2022, though, it will have 3 tiers of Intel Arc A-series laptops that should meet most budgets. But Intel also seems motivated by a mission it began in 1996 when it first introduced the USB spec. To complete the platform and present a truly Intel plus Intel experience, the company needs to come sprinting out of the gate with performance and features that will turn heads. And if it succeeds, then people will definitely be paying attention when Intel finally launches its dedicated desktop and workstation GPUs later this year. So beginning today, Intel is going to launch multiple laptops powered by Arc A-series graphics. And Intel co-engineered these with OEMs like Samsung, like Dell, Acer, Lenovo, and MSI. And Clevo is also in the list, which should mean that we should eventually see some A-series offerings from the System 76s and Tuxedo computers of the world too. So the Intel Arc 3 A350M and A370M graphics will be the first ones to roll out, followed by more powerful Intel Arc 5 and Arc 7 laptops landing in early summer 2022. Every single Intel Arc GPU will have hardware-level support for ray tracing and DirectX 12 Ultimate. Those are the very basic details, but I want to dig into more on the features that Intel is bringing to the table for both gamers and content creators. Now, I want to start with display connectivity and high-resolution support. And I'm leading off with this because I have recently seen way too many quote-unquote high-end hardware products aimed at content creators that are launching without next-gen display connectivity. And yes, I'm deliberately calling out Apple's Mac Studio with its HDMI 2.0 spec, meaning you're limited to a maximum of 4K 60 Hz through the HDMI port and a maximum of 6K 60 Hz through the Mac Studio's Thunderbolt connection. Meanwhile, Intel's Xe display engine kind of makes a mockery of this by using HDMI 2.0B and DisplayPort 1.4A. So in practice, the kind of display support you can expect, you're looking at things like up to 1440p and 360 hertz, up to 4 connected 4K 120 hertz HDR displays, or up to 2 8K 60 hertz HDR displays. That is awesome. All right, let's talk about gaming. One of the most beneficial features recently added to the PC gaming ecosystem has been image upscaling technology. And you know this as Nvidia DLSS and AMD FSR. Both of these function as almost a free hardware upgrade, delivering better performance and enhanced visual fidelity at higher resolutions. And this is especially true on desktop Linux and on the Steam Deck, where AMD FSR can be applied universally across almost all games. Intel is sticking its foot in this image upscaling door with something called Xe supersampling, or XeSS. Unfortunately, it won't be ready to launch until early summer. Fortunately, it will launch with more than 20 games. Plus, Intel says that they will open the XeSS development kit industry-wide for anyone to implement. Now, like NVIDIA's DLSS, it is an AI-enhanced post-processing effect that, when running as intended, can allegedly deliver some remarkable results by enhancing each pixel. I'm going to roll a demo that Intel sent.
On the left is native gameplay rendered at 1080p, while on the right is XeSS enhanced gameplay upscaled to 4K. As we zoom in, focus on the shield and the wall. Notice the additional clarity and detail that can be seen with Intel XeSS on the right. With Intel XeSS, you get better gameplay at higher resolutions.
Now, this particular demo is running on an Intel Arc 7 system, but I think the technology should be just as useful at lower native resolutions like 1080p. Okay, 2 more gaming features, and these are big ones to me. The first is called Speed Sync, and Speed Sync seems targeted at high frame rate games. You know, think about competitive shooters like Overwatch, Apex Legends, and CSGO. And it might remove the reliance on in-game VSync, because Speed Sync, for starters, it works on any display, and it lets the game run as fast as possible, but only shows completed frames on screen. Not only does this result in lower latency and reduced input lag, it also removes screen tearing. The second one is Smoooooth sync. So a screen tear is a distracting artifact that happens when a game renders a frame out of sync with the monitor's current refresh rate. Now, unlike Speed Sync, Smoooooth sync doesn't eliminate screen tearing. You'll still see every single frame. Instead, it blurs the line that you might notice on the screen using a dithering filter. Now, all I can show you right now is this simulated image. It looks convincing, and in motion, I would wager that a distracting screen tear would probably go unnoticed with Smoooooth sync activated. Now for the part that I think is completely awesome that I unfortunately doubt will see the light of day on Linux, but let's talk about it anyway. It's called Arc Control. It is the software suite that gamers probably are expecting. It ties together the Intel Arc gaming experience, and it's an overlay, it's a software suite that should feel familiar to those of you who've used GeForce Experience or AMD's Adrenalin software, except that Intel's take on this looks a lot less bloated than AMD's offering, and it doesn't require a pesky login like Nvidia's app, so applause. Arc Control is set to deliver auto updates for game drivers, performance tuning, a game library that aggregates your system-wide collection across multiple clients like Steam and Epic Games, and even a fully featured creator studio. So this means you can stream directly from Arc Control and record game highlights. Here's a few features that stood out to me. It's got a modern overlay UI, so it's instantly accessible with the Alt+I hotkey combo. There are user-defined driver updates, so you can select automatic, manual, or scheduled updates. Performance monitoring on here looks really slick, and it supports a real-time overlay with a hotkey. Here's the real cool one, and God, I hope this makes it to Linux. Arc controls Creator Studio. It takes aim at NVIDIA Broadcast with a virtual camera that can blur or replace your background, and it's got auto frame functionality that can follow and track your movement and reframe the scene if necessary. That kind of stuff is awesome. So before we look at some features that will benefit content creators, let's take a quick look at Intel's internal benchmark results for Arc 3 graphics. That's the lower performance tier that aims to deliver solid 1080p gaming. So you can see here, Hitman, Doom Eternal, F1, Age of Empires 4, Destiny 2, that's probably The Witcher 3, Strange Brigade, Final Fantasy 14, and Wolfenstein Youngblood, all mostly on medium quality settings, all delivering a solid 60 FPS. Now, I'd hazard an educated guess that the A370M can probably run just about anything at 1080p with medium quality settings. Higher if it uses Intel's XeSS or it's just a superbly optimized game like Doom Eternal. Now let's look at a few higher frame rate competitive titles like Fortnite and Rocket League. And here we're seeing 90 plus and above, which is solid. It's also worth mentioning that you'll find these Arc 3 GPUs mostly in thin and light, ultra portable class laptops, which makes the performance here pretty impressive. Okay, let's move on to content creation. And this is a bold one. Tom Peterson brazenly calls the embedded XeMedia engine, quote, objectively industry leading. And I'm not really inclined to disagree with him. Peterson's reasoning likely revolves around the included AV1 support, and this is a big deal, as Intel is officially the first in the industry to support hardware encoding for AV1. And AV1 is a next-generation, open, and royalty-free video codec. It's backed by a group called the Alliance for Open Media, and that includes giants like Amazon, Google, Apple, Facebook, Netflix, Microsoft, Nvidia. It's also a big deal because AV1 looks objectively better than long-in-the-tooth staples that we're using like H.264. It uses objectively less bandwidth when streaming and consumes objectively less space. This is best demonstrated visually, though, using Elden Ring as an example. Check out this short clip, and I'll be right back.
This is an example of AV1 game streaming using XSplit Gamecaster versus traditional H.264 game streaming. This game is called Elden Ring, and both streams have been captured in XSplit at 5 megabits per second. As we pause, you can see how much more clarity there is in the AV1 stream. Look at the rock wall on the right and the bush in the foreground. You see more detail in each of those areas. Pausing again, look at the details here in the background. The trees, the rock wall, the floor. I think it's safe to say that everything encoded with AV1 looks better. Look here at the blades of grass, and you can see on the right-hand side that AV1 looks sharper with less artifacts.
For game streamers and content producers, this means a better overall image for your audience with less CPU consumption and less bandwidth consumption. What's remarkable is that AV1 hardware acceleration is 50 times faster than software-based encoding. And the good news on that front is that Intel has already worked with developers to get AV1 integration into FFmpeg, Handbrake, XSplit, Adobe Premiere Pro, and DaVinci Resolve. And yes, I am an OBS fanatic. I use it all the time, and Tom Peterson confirmed to me that Intel is currently working with the OBS team to get AV1 integrated there too. I'm hoping we get eventual support from awesome open source video editing apps like Olive and Kdenlive as well. As you'd expect by now, every Intel Arc 3 powered notebook is also designed to deliver much faster performance when it comes to handling video files, as opposed to laptops that are powered solely by Intel Iris X integrated graphics. 4K transcoding tasks with software like Handbrake and DaVinci Resolve should see up to 1.6x boosts in performance, but things get really interesting when the compute engine joins the party. Intel says that when employing effects like auto reframe and scene edit detect in Premiere Pro, users can see up to 2.4x gains in performance with Arc graphics. And that's not accomplished solely from brute horsepower. It's in part, this uplift is accomplished with Intel Deep Link. Now, think of Deep Link as a suite of capabilities meant to create synergy between your CPU and your GPU. Here is a brief breakdown of each feature. Dynamic power share. This intelligently adapts to performance demands by shifting increasing power bias to the CPU or GPU depending on the workload. So the system polls your CPU and your GPU every 100 milliseconds and it acts accordingly. So 10 times per second, it decides what the optimal power balance should be for the next 1/10 of a second. Ideally, the result is that neither the CPU or GPU ever gets starved for power, and that maximizes the performance of its workloads. Okay, hyperencode. I like this one. Intel doesn't want to leave any transistor behind, and they want to identify any underutilized capabilities in the system that they can turn into usable real performance. In a nutshell, hyperencode is the process of combining media encode engines from both the CPU and dedicated Intel Arc GPU to maximize performance. Simple as that. And then there's hypercompute, and this feature, it seems similar to hyperencode, but instead of utilizing media engines, hypercompute engages all the available compute engines or AI accelerators. And this is frankly a complicated concept that I'm still trying to wrap my brain around. Still, the results look impressive. Intel demoed software called Video Enhance AI, which uses machine learning to upscale a video's overall quality and resolution. Imagine the compute power that you need to decompose every single pixel into multiple parts and then intelligently denoise and enhance each piece and then recompose all of that into this higher resolution video and also increase the frame rate at the same time. It's quite a workload, and Intel is leveraging an API that is open, by the way, that any software can tap into in order to maximize performance of these kind of AI-driven tasks. So if you're watching this, you know that my primary coverage focus is Linux. It has been since about 2018. And I had several questions for the Intel graphics team. Some of those were answered during the press briefing, and some responses I'm still waiting for. The biggest concern I think Linux users are going to have is whether or not their favorite desktop Linux distro will be supported on day one. And I don't have a direct, concrete answer to that, but I would point to Intel's pretty solid track record of great Linux support, from motherboards to CPUs to network and Bluetooth modules. So I'm confident that the answer should be yes. And that confidence is buoyed by the fact that Intel has already spent months contributing code to the Linux kernel in support of the Arc graphics stack, including resizable bar support. So my educated guess is that people using kernel 5.17 and Mesa 22.0 will be good to go. But like I said, I still have to get a solid answer, and I hope to in the next few days. Now, it's also, I think, crucial that we see feature parity between Windows and desktop Linux, especially with stuff like ray tracing, AV1 encode, and XeSS. And I did get a response from Intel on this, and they say ray tracing, XMX, AV1, all these features are supported in Linux. Some gaming-specific features are not supported at this point, but we will be looking at opportunities to support those on Linux as well. It's not the most satisfying answer, but at least it's an honest one. So for the immediate future, it looks like those of you interested in Arc graphics for content creation and compute should be covered, but we won't have a complete set of gaming features at launch. All right, wrapping up, I know this has been a long one, and if you made it this far, really, really appreciate you watching and listening. Intel delivered just a metric ton of features for us to unpack. So I hope this overview has given you enough to, to chew over and contemplate until actual hardware arrives at Linux for Everyone HQ, which it will. Anyway, what I'm seeing through my eyes is an energized Intel graphics team that wants to innovate instead of just being content playing catch up with the competition, If Intel can truly deliver on these promises of synergy between its CPUs and dedicated Arc graphics chips, it has an entirely new market to start chewing into, and we're going to benefit from that. Intel will need to drive developer adoption of its APIs and its various software technologies and prove to gamers that it offers genuine competition at fair prices. At any rate, having a third player entering the discrete graphics arena is downright exciting to me, especially a player that has been very supportive of Linux and open source. I am here for this ride, and I'm really anxious to see where it takes us. If you guys have any questions or comments about Intel Art Graphics, leave them in the comments, and I'll do my best to reach out to my PR reps and try to get some answers for you guys. I will let you go. This has been a really long one. Until we chat again, take care, okay? And take care of each other. See ya.